Hello everyone, and welcome to our course on commercial open source software startups and how to spin off such a startup from university. We are at the beginning of the lectures for this course. The course has three main parts, of which this one is about the software industry. The first lecture, as you can see, is exactly about the software industry, followed by a lecture on software products, then on software vendors, and finally on another topic, specifically the business models underlying software vendors and related companies. My name is Dirk Riele. I'm your host and the creator of this course. So in this first session of about an hour, we will clarify what the software industry is, look at its history, which is intriguing, and then at the main players that populate this industry. Then we will look at software products as the main creation or a main creation of this industry, including services to operate products. And we will look at one core strategy, software platforms, and the necessary support they need by way of software ecosystems. So, what is software? I'm pretty sure you have an idea. In particular, most of you will have an engineering background, so you're probably thinking about software from a technical perspective. It's instructions to make a computer do something. It can be in textual written form, then it's source code, can be compiled, then it's binary bits instructing a computer what to do. And that is important because these properties will be relevant later on. Software is built from components. You put components together to assemble larger and ever larger programs and services and so forth. Next to this engineering perspective or technical definition, software is also an economic entity. And specifically, we call it a digital good. And as a good, it can be bought and sold, which is a big part of the foundation of the software industry. I'm not sure I need to tell you much about the significance of software. It's pretty much everywhere today. It's not necessarily visible. It's inside physical devices. It's in the infotainment stack, that software that operates the center console of your car, or it's in mobile phones, or it operates factories, it operates medical devices, all of these. So software is everywhere in the physical world, an integral part of how the physical world operates. Software is its own thing in that it runs on computers and you run it for its own purpose. So you run spreadsheets to do calculations and they don't need, they're not tied to a physical device except that you run it on your laptop or some workstation. And also increasingly, software is operated as a service for you. So you don't even hold that software in your hand any longer. Someone else does that for you and lets you access it through the internet. So that would be all kinds of services, from email, through social media, through games. And as such, it is economically valuable because people pay for it, pay significant amounts of money for it. So increasingly, we're not only using that, we are living in a world dominated by software, where everything would come to a screeching halt if the software wouldn't do what it's supposed to do. And so comes in the business perspective. Businesses, some type of business called vendors, we will see that, sell products. So software can be a product. First, a product is a man-made artifact. So we create it somehow, and then we sell it to customers in a market. Without customers, no product. If you don't have anyone to sell to, you don't have a product. Markets are already a way of structuring customers because there might be different types of customers and the products may have to look differently depending on who you're selling to. Products, this is important later on, have a life cycle. which means they are born, so there's a start date for the product. They grow and mature, and they may eventually die, but we don't know when they will die. The hope typically for every product is that it's as long-lived as possible to recoup any investment into creating it in the first place. So rarely do companies put end dates on products. A software product then is that, a product, but with specific properties, most notably, unlike, say, a physical device like a coffee mug that could be sold to you as a product in a department store. A software product is virtual, it's intellectual property, so it's not physical, which in some sense is good. It does not rot, it does not decay, or it is weird. You can create copies of software products at near zero cost. The cost is to get to that first copy of the software, the investment into developing the software. But once you have that first copy, creating another copy is not that hard. And software is also extremely malleable. It can be changed comparatively easily, and that has its own consequences that are of interest to us later on. So then, the software industry, that's the place that creates software, turns it into a product, sells it to you, provides services around these products. The software industry is the set of all businesses that provide you with these software products, provide you with services, and these services around software can be of different type. They could be operating the software for you, they could be customizing the software for your needs, etc. And the software industry, or the players in the software industry, do that for themselves as much as they do it for other industries that are not the software industry. Other industries are oil and gas, so energy, or logistics, or automotive, or advertising agencies that are other industries. The software industry, unlike some of the others I just mentioned, is also different again, or not so different in that it simply has properties that not everyone has. Specifically, it's highly concentrated and highly internationalized. So there is a so-called winner-takes-all effect that is happening. It's if you are the big gorilla, then it's really hard to compete with you, and you will increasingly have the money, the revenues flow to you just because of your power and position. And that makes you immediately easily a global, internationally operating company. You're not tied down into a specific regulatory environment, meaning countries or even smaller demographics. Software is also quick to change, which means it has a high speed of innovation as a first derivative of modifying or developing software. It can change quickly, hence you can innovate quickly. And also we see that software really is creeping or, well, expanding into new domains all the time. And you can argue that while you usually think of industries as standing kind of next to each other and you segment the world into these big different industries, you can argue that software is in every other industry and has a kind of foundational role increasingly for all these other industries, which makes it a very unique and very different industry. It's big. The way to look at size is to ask how much money is spent on products and services from an industry. The outside perspective on what I call here the software industry is IT. So if you are not from the software industry, you look at, but you're an outsider, you look at the software industry and call them IT, information technology. And so you have a budget as a company, let's say a financial service company like a bank, you have a budget to spend on IT. And the accumulated budgets of all companies across this planet and consumers across this planet, the accumulated budgets is the total market size of the software industry. And it's huge. As you can see here, the total spending in billion is 4,000, more than 4,000 billion US dollar expected in 2021, according to one industry player called Gartner, see the footnote, who is a provider of materials, information about the software industry and other industries. So it is huge and it keeps growing. These are pre-corona data, but if there was some industry that benefited from corona, then it's the software industry. So this will not have slowed down, quite the opposite. And this idea that you've just been hearing from me, that software is super important, was nicely put or put in words that are easy to remember by this Silicon Valley egghead called Mark Andreessen, a venture capitalist of Andreessen Horowitz. And he notably said in 2011, software is eating the world. By that, he meant what I said a few slides earlier, software makes it into every other product. So whatever the other product is, there's a software component to it, and hence the software industry is earning money if that other product from another industry is being sold. Software is everywhere, software is eating the world. The inverse perspective comes from traditional companies who then realize, oh, not only do we need software for our operations, we really need to make them an integral part of our business model. We cannot not be a software company. That's Jeffrey Immelt, now the former CEO of General Electric, saying that GE needs to be in the information business, and later on saying very explicitly it needs to be a software company as well. Next to, of course, having its traditional products, but it also needs to be a software company. And that is true for about every large company on this planet, more or less these days. A recent example in Germany is Volkswagen creating its own business unit just for software development. And so they realized that they have to think the car, as they say, from the software perspective. There's a first derivative of this observation that software is eating everything, which is that not only is software in every product, software is also different from the other parts of that product then in that it's digital, virtual. And as I explained, comes with this high innovation speed. Think about some physical device doing whatever circuits, designing a circuit, manufacturing the thing, putting it out into the market, depends on the device, but weeks, certainly more likely months, sometimes years. Software at the push of a button can be compiled and deployed to a product within minutes and sometimes seconds. Software has thereby a higher, much higher delivery speed, so you can innovate much faster. As a consequence, not only is software making it into all these products, software is pushing out of these existing products traditional features that were done in hardware, because hardware was so much slower to change. If you need to keep up the speed of innovation, you will replace your old traditional physical components in a product as much as you can by software, because using over-the-air updates or any form of on-demand deployment or continuous delivery, using any of these forms, you can speed up the innovation in your products out there as they're doing their service with customers. I call this the first derivative of Andreessen's quote of software is eating the world. Software is kicking out parts of existing products, replacing it because of its unique property to be so much easier to change, so much easier to deploy, so much easier to deliver the economic value from any investment, some programming that went into this. And beyond that, we already know all of this. Software is not just important, it's in society. It is a tool. Like a tool, it can be used for good or bad. It can empower you, and it can put you into a gerüst. Yeah, it can put you into a straitjacket. You can have a highly efficient financial services system because of software, and we can also put you under a social credit system which prevents that you'll ever get a bank loan if you need it. So it is really has made its way into society, where it can be used for better good, to connect people and to isolate people, to let people learn about other human fellow beings, and to put people into a bubble where they never hear anything from, unlike those from anyone else who is not like them. One important thing to say here, in my opinion, is that for all of this to work, things like internet and email have become basic utilities, just like electricity and gas or so, to power your home. The software industry is, comparatively speaking, not so old. The term software was first mentioned in 1959, and software as its own independent entity came into being, or into the minds of people, in 1969, when the US Department of Justice cast a landmark decision which separated hardware from software. Until then, hardware and software were viewed as inseparable. After that decision, people realized that these are two separable components that can be sold individually, and in some cases must be sold individually to avoid antitrust lawsuits. Over the course of the next decades, we then saw the rapid development of software, all the way to today's cloud computing. We saw that different COSS architectures dominated the industry, and how products were cut and sold to customers. In the 80s, we've had initially something called vertical integration, where companies built complete stacks of a so-called customer solution, and that changed to a best of breed situation where there was horizontal integration, layers of components from different vendors. I'll discuss that in a bit. We also saw the emergence of monopolists, at least for a bit, and most notably Windows, or Microsoft's Windows, as a dominant operating system in the 90s. But in the 2000s already, we saw more diversification again, and the growth of open source software. And in the 2010s now, or going into the 2020s, we see how cloud computing is eating the world, which brings back, at least in parts, the vertical integration of the 1980s. So what does that mean? It's actually important to understand how large software systems that do a job for a user are structured. And in particular, we need to understand the difference between vertical and horizontal integration. In the olden days, until the 1980s, roughly, or into the 80s as well, product vendors like IBM, International Business Machines, and DEC, Digital Equipment Corporation, would provide complete solutions to customers. The solution is this combined thing here, which does everything the customer wants, and then they are fully satisfied. They don't need anything else. Such a solution consisted of many components logically. That was visible to everyone who worked on it, because that's, for example, how you would create different teams because you would need different skills to build hardware. To build the computer, it's hardware. You needed one set of skills, mostly electrical engineering skills, but then you would also need an operating system. So you needed programming skills, systems programming skills, but then you also needed business applications that actually do something for the customer. And so that would be application development skills and understanding of business needs of customers, etc. So you'd have these layers, but they would all be put together and developed and put together by the same vendor into one coherent package that was being sold to customers. As a consequence, in front of a customer in the 80s, still IBM and DEC would just compete, and it would be a all or nothing sale, in that the customer would say, I go with IBM, or I go with Digital Equipment Corporation, and that's it. Now, that changed in the 90s when users and customers didn't like the original vertical integration any longer. What they didn't like is that in vertical integration, everything had to be from the same vendor, all right, and everything had to be good. So that meant that IBM or DEC needed to be good really on all these layers of the so-called technology stack. They needed to develop great hardware that never fails or rarely fails. They needed to develop a superb operating system that wouldn't stop applications dead in their tracks. They would need to understand the customer needs for the applications. So customer empathy, which you usually don't have if you're building, mostly doing hardware and so forth. So having all these skills in one building or in one company is actually really hard. As a consequence, in the 90s, an alternative solution developed, so-called horizontal integration, where the vendors started to specialize on the different layers of this stack. So you really can see the layers here, where hardware is one layer, operating system is one layer, application is one layer, and then actually customization services on top of it are yet another layer. And horizontal integration meant that you had to introduce defined interfaces between these layers so that a different vendor, a different company could build an operating system on the hardware different from the company which created the hardware. So Microsoft could develop an operating system for hardware created and produced by IBM or Dell or even Samsung possibly today. And this was only possible with nicely defined interfaces that were well understood. And then Microsoft could become the company that specialized in developing an operating system. And that's the so-called best of breed approach, because now a customer can choose in each of the layer the software or the product, the hardware that they like best. So they could use Microsoft Word on Windows running on Dell computers. And then they would hire Accenture to customize it for their needs, maybe. So this way, the resulting stack combination of these things would be really, really good on each layer, at least according to customers and their needs. But of course, there was the challenge that maybe the integration didn't quite work out so well, which is why you still have services. And we see actually that this back and forth between on each layer, I want the best, that would be horizontal integration. And then I also need everything to work together smoothly. That would be vertical integration. That tension is right now making the pendulum swing back at least a little to vertical integration with cloud computing. So you can see how the so-called hyperscalers, meaning cloud computing services provider, starting from the hardware, are building up more vertically integrated products that don't necessarily reach into the applications, though some of Google does, but clearly cover the lower layers, so infrastructure, platforms, and to some extent also software as a service as it's called then. The complexity of this in real life is amazing. What you can see here, it was taken from the website of the Cloud Native Foundation, Computing Foundation. Show and tell picture of the different components for different aspects of maintaining a cloud computing stack. And as you can see, it's just hundreds of components. This is not complete, and you can break it down further. So it's just a large, complex undertaking to put all of this together. Reality is always much more complicated than my simplifying slides can illustrate. And when you look back on the economic history of the IT industry, we need to take note of a bust. Well, initially a boom, so that turned into a bubble that then burst, the so-called dot-com bubble in the late 90s and early 2000s. People back then, for the first time, really realized broadly, meaning stock markets took notice, for regular people, that the IT industry is winning big. And so with the internet being the new thing on the block, people invested like crazy until eventually it became so overheated that people realized that this may not actually be based in reality, and the investment bubble burst. You can see here a chart of the total capitalization of the NASDAQ composite index, a stock index consisting of software industry players mostly. You can see in 2000 or near 2000, at the height of the bubble, the value of the NASDAQ was, composite index was at around 5,000, and then it fell to 1,000 3 years later. 20 years later, it's at 12,000, or roughly nearly at 12,000. And so you can see it has recovered nicely from the dot-com bubble and burst. There was another recession in between around 2008, but IT, or the software industry, has come back really well, really nicely. And here on the right, you can also see the main players of that industry, of that in that index, not of that industry. So who are they, the main players? Let me first classify them. So there are the providers of standardized products. And what that means is they are selling the same thing to a market, more or less the same thing to a market. And one part of these are the so-called independent software vendors. So software vendors are the developers of software, which they then sell on to customers. The other standardized product providers are cloud service providers who operate software. So you typically these days subscribe to that service, and then you can use that service and the software. They're sometimes called the internet companies. There's a lot of names going around, and not always clear. There is obviously a strong interdependence, because cloud service providers often, or usually these days, develop their own software. So it's merged at the hip to be both an ISV and a cloud service provider. Next to the provision of these standardized products, there are customized products, meaning work done for customers that's specific to the customers. And there are two types. So in general, these are the software consulting firms. And then there are two types, which are the development services firms. So they develop custom software. And then there are the implementation services firms. These are firms that take an existing standard product and make it work, adjust it for the customer. Next to these core companies, product vendors, consulting firms, there are nonprofit organizations that make the world turn. And these are standards organizations which bring us norms and standards, the regulatory bodies which regulate the market. Usually these are governmental agencies. And then there are certification agencies who define certification programs, usually based on the output of the standards organizations. So here are, by a list from Wikipedia, the top 10 largest independent software vendors. So companies who have traditional software products they sell to customers. And as you can see, it's strongly dominated by American companies. Microsoft, of these American companies here, so in these 10, of these 10, there are 8 American companies. Of these 8, 7 are based in the Silicon Valley. So you can argue it's not the US, it's actually Silicon Valley, which runs the world here, with the exception maybe of Microsoft, who is based out of Seattle, but of course has a subsidiary in Silicon Valley. Not included here are companies with a strong consulting arm like IBM, or the internet companies, meaning those who focus on cloud computing. That's a classification problem. These internet companies are not small. You can see some examples on the right here. So Google and Facebook, and to not always use Amazon Web Services, I chose Alibaba.com here. So the cloud computing arm of Alibaba. These internet companies are by now equally big like the vendors, but their product is provided as a service. So kind of need to realize how standardized products traditionally have been sold as a so-called license sale. We'll look at that next time, but now are being provided using a subscription model where you pay on a monthly or some other time period basis, and you never get a whole hand on the actual software. It's operated for you in the provider's data center. And these are examples for that. So Microsoft, Oracle, SAP, and Adobe are classic traditional software vendors who license out an artifact, but have turned to cloud computing now as well. And then there are the cloud computing providers, the service providers, who never in the past really provided you with a classic license sale. They were always in the cloud. So they are more recent than the service providers on the right, as companies are more recent than the vendors on the left. And they interact. Yeah? So it's all intertwined. If you have a software product that you can buy, it doesn't mean that it already will do a good job for you. In particular, enterprise software, let's say SAP's Business Suite, out of the box won't do you any good. You typically need services which turn that generic standardized product into something that fits your needs and fulfills, say, your business processes. So as a consequence, if we take something large like an SAP deployment, a customer, let's say a big bank, or let's say some oil and gas company, energy company, they might buy SAP, which means purchase licenses for use. But then they would need another company, a consultancy, to adjust or to add for that particular industry the needed business processes. SAP's Business Suite is very broad, and it has all kinds of libraries and extensions into different industries, but it doesn't cover all. These large consultancies like Tata or Accenture or IBM, they have their own SAP code written in this funny programming language called ABAP for the various industries, which they take into a job and sell to customers. Because SAP's code base is too generic for the specific oil and gas company that just purchased SAP. So there's a lot of extra development until the functionality that the customer needs is actually there. And then And a third step here, Accenture, the SAP software actually needs to be put into production somewhere. And that means customization, setting up users, setting up all kinds of properties and attributes until it works well with some particular infrastructure. And then that infrastructure needs to be operated. So for the example's sake, there's yet another company here, T-Systems, who's a cloud service provider. They will then possibly run SAP for the customer. So you can see there's one vendor, 2 consulting firms, and a cloud service provider here. In reality, you will try to avoid this complexity, meaning you will probably make the company who does the custom development and the implementation be the same, possibly even be the same as the cloud service provider. But to show you these different steps of how in enterprise software the product and consulting firms interact, I kind of broke it out like this. So in addition to vendors, in addition to standardized product providers and consulting firms, you have these nonprofits. One are the standards organization. They are a meeting point, a neutral meeting point where you're not fighting or trying to fight less or significantly less than you would in front of a customer if you're competing for that business. This is where industry meets to define standards, to make things interoperable, etc., etc. Maybe even to negotiate the use of availability of necessary patents to open up some market or domain. There are plenty of examples. The most common one is the International Standards Organization, ISO, which produces a large number of norms for things to work together well. In Germany, we have the VDE and VDA and many others as well. So these are the folks who standardize things or bring industry players together to jointly standardize things. Next to standards bodies, there are regulatory bodies, usually governmental agencies, which issue directives or suggest laws that are then put into place so that directives can be issued, which regulates how the industry works. They're trying to prevent undesired behavior, for example, prevent typically monopolies from happening, and they're trying to enforce desired behavior, for example, competition for the customer's sake, protection of privacy rights, and so forth. And so within the European Union, for example, the European Commission issued the data protection directives, and it's enforced by the Information Commissioner's Office. So that's the GDPR and all of that. In the US, you have various federal agencies, Federal Trade Commission, and so forth, the FDA, Drug and Agricultural, I'm not even sure, agency which regulates, for example, access of vaccines to the market, all of these. So they issue the directives and try to regulate everything for the betterment of society. And finally, you have certification agencies. If a directive by a regulatory body says you need to show, dear provider of medical equipment, that this is safe to use in a doctor's office, then you may have to show a product certification according to a standard. And there are agencies who basically certify that you fulfill those standards and thereby are allowed to sell into a market. So think Underwriters Laboratory in the US or TÜV Nord, TÜV Süd in Germany. And so the certification agency and the standards body obviously interact. In addition, you usually need a trainer, but that's a consulting services firm who helps you understand the certification and achieve it. All right, so since this course is about startups, we need to zero in on software products. Here you will only get a first taste because the whole next session is about software products. And after that about software vendors. A first take from a software industry's perspective at what a product is, we already gave you. Now I want to talk about who you are selling to. So products are always made for someone. And the most basic distinction here to understand is that you are selling either to consumers or enterprises. So there's either a consumer or an enterprise customer. Consumer is also sometimes called retail. I use it interchangeably. So retail customers versus enterprise customers, also called B2C. So you're a vendor, you're the business selling to consumers or to enterprises, B2B, business to business. This classification is very coarse, but it has one key aspect to it, which is consumers or retail customers usually are willing to trade their time for money. So price is key of a product. Enterprise customers often see a higher value in their time, and hence they're willing to trade money for time. Price is important, but it's just one of multiple criteria. So consumer products versus enterprise products, as just mentioned, for consumers, price is key. Usually it's cheap, while enterprise products can easily go into the millions of euro for a product. You segment these two coarse grain markets into market segments. Consumers, since it's individual people, usually you split by, say, demographics, and enterprise customers you split by horizontal versus vertical structures, which I'll come to in a second. Consumers will be really annoyed if your product does not work out of the box, and they need substantial customization. But enterprises are used to things not working out of the box and that they need to hire consultants to make them work. Actually, also in the consumer space, there are lots of products where you know that you have to pay for services in addition, but in general, people are much more picky than enterprises. So here's how to look at a consumer market. You may, for example, segment it by age. That's an obvious one. Are you selling to kids or to teenagers or to single adults or married with no kids or parents or grandparents? So age could be a key distinction in how you customize a product, how you go to market, what your channels are, etc. And in the enterprise software world, you structure by horizontal or vertical, which means you talk about either about horizontal industries or vertical industries. And what that means is it's just an agreement in the industry. It's just terminology that someone sometime made up. Horizontal means the business function. Are we talking about, for example, the business function of customer relationship management? That's more or less sales and marketing. Are we talking about supplier relationship management, SRM? That's a key business function. HRM, human resource management, etc. Every company needs that. So every company wants to sell. Every company has suppliers somehow that needs to be managed, and costs need to be kept down. Every company has an HR department. And then thinking about it vertically, you have the different industries you might be selling to. So healthcare or financial services like banking or insurance, energy, automotive, these are all different, distinct industries that have their own requirements. All of them have a need for sales processes and human resource departments, and usually also engineering and what have you, which is why you get this nice matrix. Yeah? You get the columns, the verticals by industry, and you get the horizontals, the rows by business function. And you could specialize on CRM in the energy industry. If you want to go broader, you go for CRM and financial services and energy and automotive. But of course, in the end, you might go for CRM everywhere. So that would be Salesforce, trying to provide customer relationship management software, increasing other stuff as well to pretty much every industry, which is why most companies choose to have a business function or horizontal industries focus. Most companies take this horizontal focus. Only few try to take a purely vertical one. Here's one example for a vertically focused company called Avalok. That's a Swiss provider of banking software. So they are focused on the banking industry, and they will try to provide to banks software for every aspect of the business. But that's the unusual variant. Usually, new companies come up, or traditional companies have focused on, existing companies have focused on this horizontal, because it's I'm not entirely sure. I think it's probably because it's simply the requirements for CRM don't change that significantly across verticals, while understanding each business function just for, say, banking is much harder. But if you're a bank, maybe you like the idea of that one-stop shop Avalok, which gives you all the software you need for the operations of your bank. Earlier, I already used a term that I wanted to clarify called the solution. That is sales speak, if you will, but it's common and needs to be understood. In this course, I will talk about products that vendors build and sell, or that cloud computing service providers build and operate for you. Customers really stopped liking or the term product when they realized in the days of horizontal integration that a best of breed approach gives them all these great components, but no guarantee that they work together well. For these different components to work together, say the hardware and the operating system and the database and the application, for all of that to work together well, you needed to hire yet another services company which integrated those, ironed out any bugs and any integration problems, what have you. And this whole package, the different components with the services that made it work out well and nicely, that's usually what customers want to buy, and they call it therefore a solution to their needs or to their problems. Not products they buy, but rather a solution to their problems. Of course, whatever a solution is, you can still sell customers crap. Well, maybe not for too long, but the point is it's just a term, but it sounds so much nicer in customers' ears that they get their problem solved rather than product sold. So you may have wondered why the IT industry, why the software industry is so big and so rich, and why there are some companies that we all know and that have these huge market capitalizations. So where is it coming from that this industry has these network effects where winner takes all plays out, and you can become very big and very hard to displace? And a key aspect of that is the idea of a software platform. So we've talked about products and maybe also business applications that provide value to customers. So customers, when they want to buy the solution, then they think mostly about the actual business applications that lets them do stuff. If you're a bank, you need an application to manage the loans you give out to customers. So that's what you care about. You don't care about the data center software or the operating system behind it. Well, you quickly realize you have to care about it, but it's not why you're buying software in the first place. You want that business application for loan management. However, given the complexity of software, we all know that building vertically integrated stacks is a lot of work. And rather, we have different vendors specializing in different components of the stacks. So there are companies like Avalog, which will provide a business application, but then they will build on other people's software, like an operating system by Microsoft. And that would then be a platform, so-called platform they build on. This platform gives all the applications built on top of it, or whatever builds on top of it, the necessary functions to be quicker to market than if they had to build the platform themselves. But the platform is never the top layer. And it's never why customers buy in the first place. Customers always buy because there are applications that do them good and not because there are platforms supporting applications. Yet, if you've ever thought about being a startup, or if you've listened to people, or if you listen to market speak, the stock market being talked about, you probably know that everyone wants to be a platform. Just why does everyone want to be a platform if that's not why customers open the wallets? Well, to understand that, you need to see the relationship, understand the relationship between the platform and the applications built on top of it. And that relationship is of one to many. One platform, many applications. As a consequence, if application vendor 1 sells a license to a customer of its product, and customers buy because they want that application, business application, then the platform also has to be bought. So the application vendors are basically also always selling the platform, at least those platforms they are supporting or that their application relies on. And then it's not just one application by one vendor, it is all the applications by all the other vendors who are selling their products, who then also sell the platform. The application vendors get 1/10 of the total market, but the platform is sold every time. So for every application that's sold, license is sold, that is sold, a platform license is sold. In real life, it's a little bit more complicated, but that's the idea. One platform and applications. The application get 1/10 of the revenue, the platform gets the full revenue. So then a software platform is the underlying base of this application and needs to and can only win if it makes those applications easy to develop so that the application vendors come and use that platform rather than the other one. Use Windows rather than Mac OS or Linux, or use Linux rather than, use Android rather than iOS or iPhones. And again, it is symbiotic because the application vendors, to be fast to market, to build higher quality software, they need those platforms. And the platform vendors need these applications because without these applications, the platform is useless. No customer just buys the platform. But then platforms are valuable because they make it so easy or much easier to get to market for the application vendors. Once that took hold, platforms also became an explicit object of buying, as the IT department of large companies looked at it and said, okay, you want to buy all these applications for your business, dear line of business user, but we need to operate it for you. So we want to have a say in what platforms you buy. The most common concern usually is, doesn't matter which platform, just one, please, as long as the platform works more or less, just one. So the main fear of an IT department is that the users want all kinds of different platforms because of the applications on top of it. So the IT departments usually enforced one platform only policy. So it could only be Microsoft Windows, or it could only be Linux, but not both. And that led to the, what, as we will see, ecosystem wars in a bit. Now then, who makes what money? Well, if it was as simple as one customer buying an application, well, then the platform vendor and the application vendor would both be in the mix, and not knowing anything, they would just split the revenue. But of course, as there are many more applications on top of it, you build these layers, and the further down in the technology stack you go, so again, this is the stacked layers are called the technology stack, the less alternatives there are. So there's Microsoft Windows, and then there's Linux, and maybe there's iOS or so. Or whatever the Mac OS or so. But already the next higher level, you need a database. There are many more competitors, but a database system like Oracle is its own platform as well. And then you need webs, and you need web application servers, etc. Only on top of that may you actually have the actual applications. And so the actual purchasing, the money that a customer spends has to be distributed to the different vendors in this stack. And if there's only always one operating system at the bottom, then they will earn nicely. How much? Well, let's take a look at the value of software ecosystems. So software platforms become successful, or they fail. They become successful if they succeed in building a well-working, active, and ideally, or necessarily large, so-called ecosystem on top of the platform, including the platform. So a software ecosystem is the totality of actors, all the businesses, all the individuals that use that platform, that build applications for it, that somehow are busy and related to that platform to make it work out. And what it means in terms of earning money and establishing a dominant platform is that the larger the platform, the more applications are on top of it, the more the users, customers come to that platform rather than to the competitor, and hence the more money you're making. So on the left side, you see two platforms of equal size competing, and the relevant size is the ecosystem. And the ecosystem is the combination of platform plus applications on top of it. And customers look at it and say and ask themselves, does this ecosystem have the applications that I need? And can I operate it? And in the future, will it provide all the new applications that I need? And so in the first state on the left side, they seem to be of equal size and they're competing, but then somehow things shift. So one platform is winning, which means that there are more applications on top of it. And as this dynamic takes hold, more customers also flock to that second ecosystem on the right. Creating that ecosystem is hard. It's the platform vendor who has to bow and to brown nose and support and cajole the application developers, vendors, in particular the platforms only starting out, so that they join this ecosystem and make it richer as a whole. But there is an incentive that once you are in the ecosystem, you want it to keep growing, because as customers choose an ecosystem ultimately over the other, you only become a potential supplier to these customers if you are in the right ecosystem. Of course, you can have an application and provide it into multiple ecosystems, but that's then often double the cost or significantly more cost than if you are only in one ecosystem, but it's the one ecosystem that's winning. So creating ecosystems is important for platforms to succeed, and will substantially, if it's done right and you actually succeed, will substantially drive up revenues. It's also good for the applications, but the one to benefit is indeed the platform. We will revisit all of that when we look at software strategies, product strategies, the vendors, all of this again from an open source perspective and then commercial open source perspective later on. So today I talked about the software industry and gave a short rundown of its history and who the main players are. We looked at software products, the key thing that will keep us busy in the rest of this course as well as associated strategies for platforms and ecosystems. That's it from me today. Thank you very much. And I hope you enjoyed this talk and you will be back for more lectures of this kind. Next up will be software products.